we now come to looking at the main joint in a historic building. Okay, so this is our main bit of joints in a timber frame building. We've got the wall post coming up for the truss. Got a wall plate running along which all the rafters sit on. We've got our tie beam running across the building from one side to the other. And we've got our principal rafter coming in, which is going to support the purlin. So here we've got a massive problem of how we joint all these separate bits of timber together. And so this was done in a particular way that lasted for about 400 years. First of all, the principal rafter here had a tenon on the end, and it went into a mortise hole on the tie beam, and that mortise wasn't open-ended, it was stopped at that point. If you look at the end of the tenon, you can see how it's been cut square. And so any downward and outward thrust is pushing on a bit of timber there. You're not just relying on the peg in that joint. So we've then got the tie beam coming across, and we need to tie that tie beam into the wall post and the wall plate running through the building. And so the way they did that was a quite complex joint. You can see you've got a mortise hole here, which takes a tenon coming out of the top of the main wall post. But to connect this tie beam to the wall plate, we've got a dovetail joint. You can see it there, and it connects the whole lot together. Okay, so that and that are dovetailed together. We've then got to tie the wall plate to the top of the post, and that again is done with another tenon and a mortise. So a very, very complex joint. And these tended to fail within about 20 years of the building being constructed. Why did they fail? Well, what happens if they fail? If these joints get slack, and I'll just show you how slack this one is. This was all done in green timber, but obviously on a small scale. And if we put that together, can you see now how? Okay, and that is because of the shrinkage of the timber. As it seasons, it shrinks. And the timber shrinks radially, but not in length. So the tie beam doesn't shrink any in length, the post doesn't shrink anything in length, but the wall plate is shrinking radially. So the dovetail joint gets slack because of the differential shrinkage. And so if that begins to move outwards with roof thrust, it's putting all the load on that tenon at the top of the wall post. So what's going to happen? You get a crack running down the post as this half of the post tries to stay with the tie beam, and that half side of the post tries to go out with the wall plate. And so very often in timber frame buildings you'll see a crack running down the main post from that joint. So in order to sort of accommodate all these massive joints at the top of the post, you can see the post is bigger here at the top than it is down at the bottom. This is what's known as a jowl, and you'll see these jowl posts in most historic timber frame buildings. Sometimes they're sort of nicely shaped like this, other times they just sort of swell out. And those that swell out were known as gunstock jowls, because if you think of a gunstock and they're just the same sort of shape. So we've a historic joint here that was used for about 400 years, but was doomed to failure right from the beginning because of the differential shrinkage of the timber. So it's a common failure in many historic buildings. Well, the other thing to think about is the way the joints are fixed together. And basically, they're fixed with a peg. And those pegged joints were made in a particular way. You, first of all, cut your mortise. You cut your tenon to fit. You then drilled a hole through your mortise. You slotted your tenon in. You marked up where the hole is, pulled it apart again, and then you drill the hole in your tenon off centre towards the shoulder of the joint. So when you look through the two holes, they didn't quite line up. You then used a peg that was tapered. So as you drive it in, this is going to act as a wedge, and it's going to pull in the joint tight so that it tightened the joint up against the shoulder. And these pegs are always left slightly longer than they needed, so that as the building, as the timber dried and seasoned, and any joints got a little bit slacker, you could just tap them in further to actually tighten up the joint. So this system of pegging was used right the way through history with the timber frame buildings. It's known as draw pegging. The pegs were made using a draw knife. They're not a circular dowel, as you can see. They're multi-sided, slightly tapered and pointed, and they're done with a draw knife. And so you're putting a multi-sided peg into a round hole, so that's going to tighten in anyway. And the pegs were always used dry oak, whereas the timber you were building with is green oak. So as that shrinks, it's going to shrink onto a peg that's already shrunk, so the peg's not going to fall out. The whole thing's going to get much tighter. So it's quite a complex system, and at tea break time I want you to have a go at putting that back together before you have your cake. I'll pass this round, but it just comes with a health warning. It's fairly blunt, but do be careful. You can see the side axe, it's got a flat side to it, and the shaft is kicked away at an angle, and it's only sharpened on one side of the face of that blade, so it's more like a chisel. And you used it alongside yourself, like that, to cut away the timber to create a flat surface. So the next time you go into a Watney pub and you see one of these, typical Watney Tudor makeover jobs on the pub, and you've got a beam and it's got lots of scallops in it, that wasn't done with an adze. Adzes were used for doing circular work, curved work for things like shipbuilding, etc. The adze was not used to any great extent in building houses. It was the side axe. So we'll pass that round so you can have a look at it. That's a modern one, small carpenter's one. They're much bigger that they were using in the tree felling. So once you've got your timber squared up, and getting a square out of a circle, when you get to the corners, you're bound to still have a little bit of sapwood and even possibly a bit of bark left on. Now, if you used your piece of timber just like that as a rectangle, it's green timber. As it seasons, it's going to shrink, and it shrinks radially. And so you'll get a check back to the heart. So a crack, big crack running back to the heart. So you want to release the tension as it's drying out, as it's seasoning. And so over the saw pit, over the pit, using a pit saw, they'd cut it down the centre. And that released the tension. And so you got two pieces of timber, which when they shrank, they probably go slightly rhomboidal in shape, but you wouldn't get big sort of splits in them. And if you wanted a smaller timber still, say for rafters, you'd quarter it. And again, that helped to release the tension. The only time historically that timber was cut through and through was to form things like floorboards. And that was very, very labour intensive, very costly exercise. And so in the earlier medieval period, if you sold your house and moved, you took your floorboards with you, not the light bulbs and the carpets, but the floorboards. Okay, so yeah, in the more historic medieval buildings, you'll find that the floorboards are running in the same direction as the joists, and the joists have got a rebate in them for the floorboards to sit in, and so you'd get a broad board, and then you get a narrower bit of timber, which is the top of your joist, and then a broad board, and so on. And that meant that, you know, you could just lift your boards up and take them with you. Okay, and if you want to see a building like that, in summer in Southampton, there's 58A French Street, which is looked after by English Heritage. It's a medieval merchant's house dating back to the 14th century. It's only open at weekends in summer, but it's well worth having a look at. It's been beautifully restored, and you go upstairs and have a look, and there you'll see these floorboards running the same direction of the joists, just rebated in. Medieval joists are laid that way on, okay? It's only in the 17th century that you get joists running like that. So they're running flat. Okay, so that's sort of conversion of the timber. So you can see on happens to be a barn, you can see that here the jowl post has still got a bit of bark on it, and these braces, these wind braces, again, they've got a bit of bark and sapwood. These jowl posts with this sort of flared thickening at the base, the way they got those was to fell the tree very low down. So you get the naturally the timber's flaring out for the root stock. And if you cut it at low level, and again, if you think it's quite sensible because of the tree growing and blowing in the breeze, the toughest bit of all is the root stock, you know, to keep it upright. And so all you're doing is cutting your tree down, and then you're using it that way up to create your post. So this is the new alternative to UPVC for your windows. The trade name is Accoya, ACCOYA. If you Google it and find out all about it, it tells you all about the process, but it's an acetylating treatment for the timber. And they're beginning to get it down to more or less the price of hardwoods now for doing things like window joinery. A lot of joiners are now beginning to pick it up, and you know, if it's a listed building or a historic building, a heritage building, they're beginning to say, well, use this, you know, come to us, we'll do you a proper joinery replacement job, like for like, in this material, rather than, you know, putting in UPVC or something of that nature. So I'll pass it round. You can see the surface as cut, and then the machine surface. And if you feel it, it's a very tight texture to it, and very, very smooth.